So the next thing we want to talk about is hardness. That's lime, calcium, magnesium, iron, and those are heavy metals that are in the water. And there's a way to measure those, and we measure it in grains. Now, anciently it was a grain of barley, and 1 grain of barley was equivalent to 1 1/3 grains of wheat. So what that means, if somebody said your water was 10 grains hard, that would mean in 1 gallon of water, there was the equivalent of 10 grains of barley by weight. Now there's a way to measure that. So here's a sample of water that we've precipitated the hardness out of. So this is the hardness that ruins equipment, cappuccino valves, ice machines, and this is what everybody's fighting as an expense. Now this could be at one location. Now you'll notice we've done it with another sample from another location. And the two samples of water are very different. If water was 90% of the recipe, you can see that the two beverages could never have the same taste because the water is going to have different content and a different amount in it. We're able to fix that. We're actually able to measure the amount of hardness in water. We use a powder called a reagent, and that turns the water lavender. Then we use a titrant solution, 1 drop at a time, until the water turns blue. And when it's blue, that number of drops is the amount of grains that's in that amount of water. Now we're going to show you a short video that compares the Everpure treatment of hardness compared to the Arctic Peaks treatment of hardness. We're able to measure the hardness in water before it actually goes through the filter. So we take a pre-measured amount of city water, add the reagent to it, blend it in, then we add the titrant solution 1 drop at a time until the water turns blue. In this sample, it turns blue at 16. So the water is 16 grains before it goes into the Everpure filter. Now we're going to go to the scale inhibitor sample port and draw another measure of water and test it compared to the water going in. We take a pre-measured amount of water from the scale inhibitor, we add the reagent, and then we add the drops of titrant solution 1 drop at a time. You'll notice though that it turned blue at 15. We had to wait a little bit. It turned lavender again, and then we added 1 more drop. So from this sample, we see that the water is 16 grains hard going into the filter and 16 grains coming out of the scale inhibitor. Now we want to examine the water that the Everpure serves to the carbonator. Now we have to draw water from the carbonator, and from that we're going to draw a pre-measured amount of water, add the reagent to it too, and add the titrant solution 1 drop at a time until the water turns blue. So after having gone through the Everpure filter, from the scale inhibitor to the fountain, you would expect to see some level of reduction in hardness in the water. It turned lavender again, and then we added 1 more drop. We see that Everpure carbonated water still tests 16 grains hard. Now, the real test. Can Arctic Peaks do better than Everpure even at carbonation? Arctic Peaks purified carbonated water comes from the same municipal source that supplied the Everpure filter. It is then put through the same testing process. You can see that the water goes immediately to blue without adding any drops. So as you can see, the hard water is eliminated.